Hi, in this video we are going to discuss about LightRAG. Before discussing what is LightRAG, let us see what is a naive RAG or a simple RAG. We know RAG stands for retrieval augmented generation. This is a type of technique where we give specific knowledge to the large language model in order to get the answer for the required query or the user asked query. We know that LLMs are trained on a vast amount of knowledge, and then it behaves like in such a way that whenever user asks the query, it answers based upon its own knowledge. But in the case where if we need a answer for a specific from the specific document or from the specific data sources, then either we need to fine tune the LLM, which is cost intensive and then resource intensive as well. It is not economical. The other way is retrieval augmented generations, where we can give the knowledge, like specific knowledge in the form of a context with the prompt, so that LLM can frame the best answer. This is in the figure you can see the naive RAG or a basic RAG system where we have a data sources, and then we have a RAG ingestion pipeline. If you want to know detail about how we can ingest data to or construct a RAG ingestion pipeline, I created a previously I created a video, so I will give a link so that you can watch that one as well. In simple, we have a data sources. It may be any kind of data. It may be a PDF document, Word, Excel, or even a database. We can connect to it, and then we can prepare in the form of chunks, and then convert it into embeddings. These embeddings are further stored into embedding vector database, and then this is a vector database, special kind of database where embeddings are stored. And after this process, now when a user asks a query, like for example, if a user want to know about something about a specific document or a specific related to a financial transaction, whatever may be, which is already embedded in the vector database. Now if user asks a query, the query will be converted to embeddings, and then again it will be used by an LLM to retrieve the semantically similar chunks to the query asked by the user, and then those chunks or those vector embeddings will be fed again with the prompt and then the user input. Then the LLM will construct the final answer and give the answer to the user in such a way that which is very related to the question asked. So this is very simple naive RAG. Now if you see in this diagram, so we have a knowledge base converted into chunks, and then chunks are converted into vector embeddings, and then along with the user question, these context also given to the LLM. So the LLM has the context as well as the query, so it will frame the answer. So now this will behave in such a way that if the LLM gets a proper context, then the user may get a correct answer for the asked question. But if the LLM couldn't be able to retrieve the proper context, then definitely you can't able to provide the correct answer. So this is one of the main drawback in naive RAG, like how properly to do the or to retrieve the chunks. There are different processes, like we can tune either by giving a proper metadata to the chunks, or there are different varieties of techniques where we can use in order to retrieve the proper chunks or proper context to feed into the LLM for the final answer. So once we give the proper context, the proper details to the LLM in order to answer the query, then we can get a more accurate answer. If not a correct answer, more accurate answer we can get. So there are different approaches to solve the problem. If the context is not that much quality enough, then automatically we don't have the answer to the extent what we expect. So that's why we go for GraphRAG. So GraphRAG was first proposed by Microsoft. The process is simpler. Like when we feed the data will be first parsed, and then the entities and relationship to those entities are taken. So we have a overall structure like what are those entities and how they are related to each other. So this will be used while retrieving the specific context based upon the user query. So when these relationships and entities are formed, then based upon this knowledge graph, the relevant context will be fetched. For example, if you see in the figure, like we have a type person and his name is Lehman, and then his title is professor, and how he relates to another person, and how what he teaches and what he works. So these are, so for example, if it creates entities and relationship based upon nodes and as well as links as edges, the relationships. So now, so with this better understanding of what the document actually contains, the LLM can able to retrieve the document more contextually relevant chunks from the database, so that while making the answer, those most relevant chunks are used in order to get the answer. So this is one step more advanced compared to normal RAG system. So now this has its own drawback. Like like we will see what it is actually. So now I just given some bullet points here. So GraphRAG handles global high-level queries especially well, and consistently performs better than naive RAG or baseline RAG. So that obviously, because we have entities and relationships, and when a user asks a query and it chases in the GraphRAG system, like in the graph, like what this particular query matches, and then based upon those entities and relationships, it fetches the relevant information, most relevant information, and then based upon that we can get the answer. That's one thing. So it offers enhanced contextual understanding and greater interoperability by grounding information within the graph index, enabling entity and relation source citations. So that is one important advancement we get here. So we know what this, for example, if you ask for a person, the GraphRAG already had a knowledge like this person belongs to this entity, like this title and all those relationships have been already captured. So based upon that, it can able to get the correct context in order to form the answer. But it is resource intensive. Like GraphRAG is often painfully slow to run it queries. It uses multiple LLM API calls. So it is obviously costly because it has to do more LLM calls in order to get the correct context, and it's extremely costly. It could cost around 6 to 7 to index a simple book having around 32K words. So that is already proved like why it is costly. And also the main drawback here is what I feel is the incorporate new data. If you want to incorporate the new data into existing graph indices, which will need to reconstruct the entire knowledge graph. That's the main problem here, especially in the GraphRAG. It has to reconstruct the entire knowledge graph, and then only we need to use that knowledge graph for further querying. So that is resource intensive and also costly if you want to put the new information. And there is no deduplication steps performed. So that's why we have to that if there are repeated elements, or if there are repeated nodes and relationships appearing in the document or in the data, then it will be there. There is no deduplication process. So these two steps, if we can able to enumerate, then we will have a very refined RAG. So that's what LightRAG able to achieve. So this is how LightRAG differs compared to naive RAG or a LightRAG or the GraphRAG. LightRAG offers comprehensive information retrieval with diverse answers, efficient and low cost retrieval. So that is a main process, how they are doing, like and also we will discuss how it has been done. And it is fast adaptation to the data and updates them in minimal reindexing. So that's one main important concept here. So in the GraphRAG, if you want to do if you want to add a new information, then you have to construct the entire knowledge graph. But here in LightRAG, we need to just update the relationship. For example, if the entity changes its relationship with another entity, then it will be updated. It is not like a GraphRAG to completely change the knowledge graph. That's how easily adapting a new data, and incremental update algorithm updates that updates only specific element instances. So that's what we discussed right now. And also one important thing is it also does the deduplication. So we will see the process how it has. We will see step by step process how it can be achieved. Now we will see the high level overview of LightRAG in a step by step fashion. So first one is text indexing. So now whenever we feed the documents that are converted into manageable chunks, and then those chunks are converted into embeddings and stored in embedding like a vector database, and there is also a process called indexing. It leverages LLM to perform indexing. So this is the main process. So LightRAG enables retrieval by segmenting documents into smaller and more manageable chunks. This chunking strategy enables quick identification of relevant content without need to go through the entire document, that obviously. So enables quick access to relevant information without loading the entire document. That's one main thing. And then entity extraction. So it utilizes a large language model to identify people, organization, concepts, and events, and detect relationship between those entities. So that will be done in this process itself. Like when we feed the document, we convert it to text chunks, and then using embedding model, convert to embedding, and then stored in a vector database. Parallelly, it does the indexing. So it extracts those entities as nodes and relationship as edges. So it forms the overall graph structure. Based upon that, it does the indexing. So now it is very useful while retrieving the relevant content. That is entity extraction. And then after that, it does the knowledge graph generation. So extract entities called nodes and the relationships called edges from the text. Generates key value pairs for efficient retrieval using entity names as indexes, and performs deduplication by merging those identical entities. So that's one more step, where if there is a entity or a node and another entity having a same common relationship is duplicated, that deduplication also is done, because no need to have duplicated relationship entities, right? So that also, so that we can compress the knowledge graph, and while sourcing or while finding relevant context, it will be easy and it will be very manageable if you have a concise form of a knowledge graph without any duplicate entities and relationships. And then this combines graph elements with LLM capabilities to enable detailed, accurate, and comprehensive answers based upon the knowledge graph. So that's why we go for knowledge graph, to retrieve the most relevant answers. So LightRAG enhances traditional retrieval by adding a knowledge graph layer. So we are having knowledge graph plus the vector embeddings. So based upon that, the combination of these two works well in such a way that to retrieve the relevant content. Instead of pulling just relevant text, it builds connections between those entities and their relationships. So based upon that, we get more accurate context. Understands interrelationships and interconnections within data domains. So these will be mainly used, like there are more real world examples, especially if you are using for insurance or if you're using for legal. We should understand the relationship between each and every nodes or entities. Then only we can able to fetch the relevant document in order to give the correct answer. So now, if in case of insurance, we are going to see how this works perfectly for insurance domain. I will show you a demo. So it can intelligently connects concepts like premiums, policies, claims, and regulations, and offer better overview and contextual understanding of complex subject areas. So this is one real world use case. Now if you see the diagram, what we discussed, the same way. So now the input documents are converted into text chunks, and then it is converted to embeddings, and then key value pairs or entities and relationships are extracted and stored in a key value pair, and then a knowledge graph was created based upon that one. And also it does a deduplicated, like if you update or if you give a new document and the document contains a new relationship between existing node and existing nodes, then that will be updated as well. Plus, if there is a duplicate entry for the same node and the relationship, then that will be deduplicated, and then it will be updated in the knowledge graph. So that way it will be more manageable, and then more updated information will be retrieved. if we have this kind of setup. So that is one main advantages over normal GraphRAG to LightRAG. So these are some technical details like we will see in the demo. So what these things contain. So the first one is I want to highlight here the key value store text chunks.json. It stores document text chunks with associated metadata such as chunk size tokens, actual content, and chunk index, and parent document ID, etc. And then we have key value store LLM response.json. It holds LLM generated summaries about the entity and relationships. It uses caching mechanism to prevent redundant indexing of identical entries. So this is one main technique how they perform this prevent the redundant information. They use a caching mechanism here. And next we have, since I'm using a demo, I'm not going to use any external vector database. I'm going to use the same like simpler version. So this one as a nano, you can see here, this is called nano vector DB storage. So here those vector embeddings are converted into a readable format in the form of JSON, which is base 64 conversion. So now if you see, it is vdp_entities.json contains vector embeddings of entities extracted from the text chunks and with unique ID, entity name, etc. And then we have relationship.json. So these two are more important. It files stores relationship between entities, linking source and target entities by the IDs to represent connections. And then finally we have the graph ML like the overall relationship graph. So we will see these things in a demo. So this is the GitHub repo for LightRAG. So they give a detailed steps how you can quickly start. So here I'm going to use this LightRAG server, which gives a graphical user interface to how you can upload and how you can see the graph itself. Before that, I want to show you this is the actual paper they proposed. So whatever we discussed, it gives in detail like how it has been constructed and how efficient it was compared to other naive RAG systems or GraphRAG. So I will share the link in the description. So now I will show you like the server. So I'm just using their own code, like how we can start the server and uploading some documents here. Yeah, so now I start a LightRAG server, which we can access a lot of information, like we can have a API endpoint, and then we can have a graphical user GUI, clean GUI, like where we can test it, and a lot of stuff. So here I will show you the documents first, what I'm using. So there I use two documents, both are insurance documents related to auto insurance. So this is the I'll make it as light so that you can see. So this is the GUI proposed by given by the LightRAG itself. So it took some time to replicate the same, because I did some changes here. I want to use OpenAI embeddings. They proposed OpenAI LLM plus Olama embedding, but I changed to use OpenAI embeddings. It took some time to figure out, because right away it doesn't work as expected. I need to do some tweaks, so then only I can able to establish and then get the embeddings done properly. I will give you detailed steps how you can replicate the same if you want to use OpenAI plus OpenAI embedding itself. Apart from that, this is not locally hosted. I'm hosting it in AWS EC2 instance. So now, if you see the VS Code here, I just started the server, and then it gives different details, like what are things you can use, and then the configuration also it given detail, like what LLM configuration I'm using. I'm using OpenAI, and then all the I didn't change any temperature settings, or I just did some changes in tokens, because it has to fit with our OpenAI embedding model. And then see, it gives embedding configuration as well. I'm using text embedding 3 small, which is they propose all of my embedding, but this is the change I did. And then dimensions. So this is one thing I did the change, and then these are all same setup. And if you see, it is running in localhost. So this is the interface, web UI interface for the LightRAG. So now I uploaded 2 documents. So these are the 2 documents I uploaded. These are both insurance documents, auto insurance documents. So now this has been done, like it says completed. Completed in the sense it does all the graphing and then embedding as well. Now we can chat. So we can ask some trivial questions, starting from simple to more complicated questions. We will see how it behaves. So now we saw the documents. What are the documents we are going to process and ask questions? So now this is the chat interface, and there are different parameters we can set up. So if you see the query mode, there are different query modes like naive, basic search without additional techniques, local, context dependent information retrieval, so which is within the local bit based upon the context. Global utilizes global knowledge base, the entire knowledge base. Hybrid combines local and global retrieval, and mix integrates knowledge graph with vector retrieval. So this is one step higher, and then passes the query directly to LM without any retrieval. If you don't want to use any of your internal knowledge, then you can use bypass. So now I go with naive, and also I prepared some typical questions in order to answer. And those questions are already tested, and then I ran through different benchmarks, so that what is a grounded answer, what should be the grounded context and answer for those questions. I will show you here. So first one, eligibility and payment. The question number 1 is, how do I ensure I am eligible for rental car insurance on both the Scotia Gold Passport Visa and Scotia Bank Commercial Visa? Are there any differences in how payment must be handled, and especially regarding reward points? So this is a typical question where it has to analyze the knowledge graph and then get the context, and also have the answer for the particular question. So now let us ask this particular question and see how it behaves. So I am using a naive approach where it is a normal RAG. Okay, it gave the answer. So in the background also we can see how it behaves. So it does the process and got back the relevant chunks and the answer. So let us see. So here to ensure eligibility, social gold passport visa, initiate rental with card, declare rental. So we will see the answer here. So you must declare the rental eligibility. Okay, for both cards, rental eligibility or loss damage waiver, the rental must be in your name as a card holder. Okay, so we will see the answer. Okay, declare rental eligibility waiver. Okay, so it gives more or less a similar answer. Okay, yeah. So now it does only the document, like here it stands for DC stands for document chunk. So now let us go for the hybrid. First we go for hybrid mode. We will ask the same question. Let us see whether it fetches from the knowledge graph. Yeah, see, it goes and queries the knowledge graph as well, so that we can get the precise answer. And also we can tune the like how the answer should be, like it should be a multiple paragraph, single paragraph, or bullet points. So let us go with the bullet points and ask for most advanced one. Hybrid combines local and global retriever. Okay, so let us see, we will ask the same question. cache screen bull ask. Okay, let us clear the cache and then ask the same question. Okay, so the key differences: Scotia allows use Scotia rewards point for payment, whereas the Scotia commercial card requires entire rental cost to be charged the card without mentioning the reward points usage. Okay. Okay, so now if you go to the answer, you must declare rental agency collision damage waiver or loss damage waiver. So for both the cards, you must declare the rental agency collision damage waiver or loss damage waiver. The rental must be in your name as a card holder. Let us see whether we get this particular answer. Decline. Okay, you must declare rental agency collision waiver or loss damage waiver. Okay, payment options you must use. Okay, coverage limit. Okay. So it gives the answer we expect. Okay, so you must initiate rental with your social call exam pickup. Okay, so the same thing it was provided here. Okay, so let us try for a different question. So question 2, maximum rental duration. Okay, so what is the maximum number of consecutive days that I can rent? Okay, so let us ask this question and test. Let us start with first we will clear everything and then we'll start with naive. Okay, coverage of 48 consecutive days. Okay, it gives, okay, not a bad answer. So this is for naive. If you go for bypass, let us see how it behaves. Okay, what it says, bypass passes could direct to LLM without retrieval. Okay, so it is having maintained the cache. Maybe it is getting from the cache itself. So now we will ask a typical question like it has to go through both the documents and use the knowledge graph as well. So here they in this document they have given only the following vehicles are not covered. So vans, cargo, the broad overview of vehicles which is not covered. But here in this they given a specific details about the exotic cars and all the stuff. So let us ask one question like whether this one like let us clear first and then ask this question. So I'm going to use LLRAG. Okay, and it is listed an exotic car which is excluded from the coverage. Okay, rental car insurance PDF. Okay, yeah, it is given here. So LLRAG fetches this correctly. Okay, so let us go for hybrid and then ask a different question. Okay, so Excalibur, we are going to use Excalibur. Okay, I'm asking a different question. Let us see how it behaves. I'm using hybrid mode. It only mentioned okay. Includes Excalibur are excluded from the coverage and disclosure of insurance. If you need specific insurance, I recommend connection to one. Okay, so this is correct. So now if you go for mix and then ask the same question. Yeah, So it uses both knowledge graph and DC. Okay, so that's one thing we see, like it is suggesting like we can't able to provide anything. Does deserve 65,000? Okay, okay. So we will see one more question from where I prepared. Okay, so claim reporting time frame and content. If I have an accident, how soon I need to report the claim, and who do I contact? Okay, so this has to give some typical answer. Let us see whether it becomes properly or not. Okay, first let us start with LightRAG. Okay, report one. Okay, so it uses only document chunks. Report claim as both in photo theft, contact claims. Okay, okay, it gives a direct answer. Let us see, like if it gives this particular detailed answer if you go for a different mode. So if you go for let us use hybrid. So hybrid says that hybrid combines local and graph retrieval and mixed and integrates knowledge graph with vector retrieval. Okay, let us go with hybrid first. Okay, reporting an accident okay, how soon you must report claim within. Okay, it doesn't provide any 48 days. That's the answer we require, right? Sorry, 48 hours. Okay, it didn't provide that answer for some reason. Oh, okay, yeah, it is there in this particular commercial code, but not in the Scotia code, passport, visa code. Okay, okay, okay. So let us try both mix. Okay, so this gives some detailed answer. You must report the claim to a claim terminal as soon as possible, certainly within 48 hours of damage or theft occurring. Okay, it gives content reporting a claim showing. Okay, claims must report within 48. Okay, okay, time frame it gives contact information. Okay, so the mix performs little bit better compared to other modes of querying. Okay, it gives that one. Okay. Okay, what specific cause are covered by collision loss dimensions from both cars if rental vehicle is damaged or stolen? Does it cover just the repairs? Okay, so let us ask this question. We'll clear everything and go with naive mode. So you can see the background process as well, what it does and what are the chunks it is retrieving, all those stuff. Okay, so collision loss, okay, coverage includes loss or damage up to actual cash value of rental vehicle. Okay, of the vehicle, liable for up to use of actual cash value. Okay, compensates you or rental agency for other actual cash value, rental vehicle, rental agency loss, towing administration. Okay, so reasonable. Okay, towing administration aren't especially mentioned in this summary. Okay, in the commercial it is not mentioned. Okay, where it is not mentioned in the commercial. Okay, gold. Okay, exclusion do not cover tax, no coverage rental period. Okay. Okay, it mentioned here. Okay, so this is naive. Even naive prepares well. Let us go for mix. So what is mix? Mix integrates knowledge graph and with vector retrieval. Hybrid combines local and global retrieval. Okay, So if you go for mix, okay, it gives in some detailed answers, so it gives limitations and exclusion. Okay, so this is far better. It uses both knowledge graph and document chunks. So yeah, so this is what I want to showcase how actually we can leverage LightRAG. So especially in a domain where it has to prepare knowledge graph in such a way that where the entities and the relationship to the other entities has to be there in order to fetch the information correctly. And also it is cost effective, and also compared to other systems, it is simple to set up, even though it took some time for me to set up in AWS using OpenAI as embedding model. I will share you the details how you can set up if you want to replicate the same. And also, if you see this particular baby way gives a detailed process, like starting from the document, how you can, it gives the pipeline status. And also one more thing is that if you click scan, it scans the input folder for any other input documents. If you have like a new documents added, if it is there, then it will again do the processing of chunking and all those stuff. So it is, so it's completed, and then all those if it is processing pending and why it is failed, those things also given. And this is what important thing I want to show you. So this is the knowledge graph actually we get from those two documents. So you can search based upon accident and theft, like what actually the nodes and the relationship between those nodes. So you can see the details in the right, like if you click on the node, it gives all the details. So definitely this will be mainly useful while retrieving the relevant context. So even though this is not that much complex, but if you have a complex document with more entities and relationship to those entities, then while fetching this will be more useful while getting the relevant context. And also in this particular thing you can search a rental agency. So what is rental agency, how it is related to each other. This is very useful, and if you want to explore further, you can replicate the same and then explore. This is a detail what we saw, and then it gives a detailed API documentation as well, like how you can use. Okay, so my goal is that to have LightRAG server separately hosted in the cloud in a secured environment, either AWS and Azure, and then we can leverage that one. So for example, if you use a company own internal documents and you want to do LightRAG chat app on top of the one, this setup will be very air gapped setup you can do in AWS, like in AWS or Azure. So you can have your own network, private network inside. You can have those setups, and then even if you don't want to use other OpenAI or any other LLM provider, you can set up your own LLM inference point, and then from that you can do that one. So that is the process how you can depending upon your own scenario you can set up. So in this API you can see you can have the scanning, uploading, like text also you can see like what it is, and these are the different API endpoints you get. And apart from that, one more thing I want to show you is this one particular thing. So here we already saw about the retrieval process, like how it can be done. So this gives in detail like how it is done. So here if you see, this is the process, especially this colored one is the process how we do the retrieving. So once there is a query, so the query along with system prompt, so they have a very good fully tested system prompt integrated into this LightRAG framework, such that it does all the operations what you need. So it has a query. So query is given by the user, and then that query will be given along with the system prompt to do the keyword extraction first from the query, and then based upon that it gets the particular embeddings as well as and it utilizes a knowledge graph to get the relevant top k embeddings, either it may be 5 or 10. In our case, if you see here, if you go to retrieval, this is for checking, I just put 10. If you want more chunks to be retrieved, you can increase or decrease based upon your own use case, and then it is finally fed into the LLM for generation of the answer. So and then we will get the response. So now if you see here, depending, this is a process, the same which I have been shown in the graph, like in the flow chart. So depending on the query mode, such as naive, local, global, and hybrid, relevant keywords are extracted from the query and are compared with the key value store. So where is key value store? If you see the key value store, I already shown you. So this is key value store text chunks. Okay, so it was I will show you like this one. Okay, so here you can see the chunk ID and the tokens it is used, and the actual content, and the document ID, and the file path. So this is key value store text.json. If you see, it stores doc text chunks with associated metadata, as we have seen, such as chunk size, tokens, actual content, and chunk index, parent doc ID, etc. And then we have key value store of LLM response as well in the form of JSON. So each response has been cached. So here you see. So this cached responses are further utilized when the user asks a variant of a different query or whatever it is. So this will speed up the process of getting the correct answer. So you can see each LLM response has been cached and then stored in the form of JSON. That's one thing. This is how they increase the response time, decrease the response time, and reduce the latency as well. Plus we see, like, I am not using any external vector database. I'm using their own provided nano vector DB. If you see here, these two JSON files, these chunks.json and entities.json. So now these are all, like, if you see here, it has a embedding dimension and all the chunks. So this is the actual chunk, and then the embedding as well. So the embedding, if you see, this is the chunk, and then this is the embedding. If you see, this is all hashed in order to store in a base64 format. Not hashed, it's in a base64 format. Everything within our own system itself. I am not using any other external provider for vector database and all. So whatever they given in the code, I use the same thing, except the tweak what I did in the embeddings. Plus, in order to use OpenAI, I need to do some changes in environmental variables. So that's the two things I did, the changes. So these are chunks and entities.json. So the entities contains the entities extracted from the text and the relationship. Okay, so now if you see here, so this is the entities, actual entities. If you see the embedding, okay, you can check here entity name, central travel account, and the content. What is the content, and these are the relationships. Okay, so if you see, first North American insurance company and targeted is Scotiabank content, all this stuff. So we have entities, relationship, and then final chunks, actual chunks. This is actual vector database content, where it has chunks as well as the embeddings. So this is more technical in the back end, what it does and how it works. So if you want to replicate the same, you can process the you can use the same code given here in the LightRAG server and web UI readme document. And apart from that, if you want to use OpenAI plus OpenAI embeddings, I will give you detailed steps how you can replicate. So this is what I want to share you with you today. And if you like this, if you get any value from this video, please like and subscribe our channel. Thank you.